This is video 4 of topic 6 on runoff. In this video we'll talk about unit hydrograph convolution, which is a topic we've touched on a few times in previous videos, but here we'll define it formally and I'll show you how to actually do it. We already know that unit hydrographs help in the development of storm hydrographs from actual rainfall events over a watershed. This is their real value. And our approach then is to take the unit hydrograph ordinates, called uj, and multiply them by the rainfall excess, Pn, and then these are subsequently added and lagged in a sequence. The calculations are typically done in a hydrological model or by hand in Excel. However, we can do them on paper too. Base flow values can be added to produce a storm hydrograph rather than just a direct runoff hydrograph if the base flow values are available for the watershed. And finally, time increments of the rainfall excess need to correspond to the duration of the unit hydrograph. In other words, we need to have 1 hour increments of rainfall excess if we have a 1 hour unit hydrograph. Now, because there's a lot to the actual calculations, it's important to remember what our purpose is here. So what we're trying to produce is a storm hydrograph made from the watershed responses to each individual hour of rainfall excess. The key points are, we know what the response to 1 millimeter of rainfall excess is. It's called the unit hydrograph. That's by definition. We also know what the response of a watershed is to 2 millimeters. It's just 2 times the height of the unit hydrograph. And if we have a storm that lasts more than 1 hour, if we have, say, a 2-hour storm, then the response to the second hour of the rainfall is just the same unit hydrograph, but starting 1 hour later. So then in practice, what we do is multiply each unit hydrograph for each hour of a storm by the correct precipitation that occurred in that hour. In the figure below, you can see these are the unit hydrographs multiplied by the precipitation values. So it rained more in the 3rd hour than in the 2nd hour, then in the 4th hour, and finally in the 1st hour of the storm, it rained the least. Okay, and then each subsequent unit hydrograph is lagged by 1 hour. So we have 1 unit hydrograph again for each hour of the storm, and each hour is represented as a little bit later. In this case, they're actually separated by 2 hours, but that's not an important point. Okay, and then finally, we add up the values, the ordinate values for each of the individual scaled unit hydrographs to get the storm hydrograph value. And so I'm showing here how I would get Q3, Q5, and Q10. In Q10, for example, I would take this value for P1 UH, plus this value for P2 UH, plus this value for P4 UH, plus this value for P3 UH, and I would get this direct runoff hydrograph here, which is the purple line with the X's. Then if I have the base flow, I can scale it to get the total storm hydrograph here as the set of circles, the sort of brown-purple circles. Okay, so that's our purpose. That's what we're trying to do, is develop this either storm hydrograph here or just the direct runoff hydrograph below it. This is the equation that we can use to do this. And so it looks a little bit complicated. It's not that hard to use though. So Qn is equal to the sum from 1 hour to the end, or to the value of Q, of Pi times U to the n minus I plus 1. If we expand this for some arbitrary n value, we get Pn U1 plus Pn minus 1 U2 plus Pn minus 2 U3 plus, and so on, all the way to P1 Uj. So you can see that they're reversed order. Higher and lowest and highest. Okay, and here in terms of the symbols, Qn is the storm hydrograph ordinate. And note that, of course, for a full hydrograph, I want Q1 through Qn. That'll map out the full shape. Pi is the rainfall excess, so remember I have to subtract the infiltration, and Uj is the unit hydrograph ordinate, or the value you'd read off the chart. A few important points. It's important to understand the subscripts here. Bedient uses the I and the N subscripts to represent the end of a time interval. In other words, not the start of the interval. P1 then means the rain that fell from a little after time 0 up to the end of time interval 1. Or in other words, it's the rain that fell from 0 to 1, more or less. Okay, so this means open interval, this means closed interval, and U1 means the flow over the interval from slightly after 0 to exactly t is equal to 1. So from the beginning of the storm to time period 1. Okay, it is very important to remember what these subscripts mean. Otherwise, it's hard to use this equation. Okay, so if we sub in a value of n equals 1, we get this very simple equation. So the flow in the first hour is the precipitation that occurred in the first hour times the unit hydrograph height for that first hour. Okay, so then the rainfall in the first hour is P1, and U1 is the watershed response to the first hour of the rainfall. If we go to the second hour, then we have Q2 is equal to P2 U1 plus P1 U2. So what do these two terms mean? Well, P2 is the rainfall in the second hour, and this is the watershed response to the second hour beginning. Okay, so this is the very first part of the response to the second hour of rainfall. And then this one is P1U2. So this is the watershed's continuing response after the rainfall in the first hour. Okay, so the second hour of the watershed's response to the first hour's rainfall. Remember, we do have this unit hydrograph curve. So even 1 hour of rainfall can lead to a 15-hour unit hydrograph, for example. And then expanding, Q3 would then be P3U1 plus P2U2 plus P1U3. Here's an example. This is the form of the equation for a 4-hour storm and a 7-hour unit hydrograph, starting with P1 and U1. The reason we start with P1, U1 is that Q0 is equal to 0. You can see it right here. So we start with P1, U1 and don't worry about U0, since U0 is equal to 0 anyway. Okay, so here's my rainfall excess. I have a 4-hour storm. Here's my unit hydrograph, and then here's how things start. So I've got Q1 is P1, U1, P2, U1 plus P1, U2, and so on. So this is one approach for developing the flow values for a storm hydrograph from unit hydrographs. There is, I think, an easier way, which is to use a tabulated form. Okay, so I usually find it's easier to make a table. This shows the add and lag much more clearly than the previous equation approach does. And so if we take that same example, a 4-hour rainfall excess and a 7-hour unit hydrograph, my first two columns would be the time, and then just the values of the unit hydrograph. So these are just for reference. Then in the column headings, I have P1 times the unit hydrograph, P2 times the unit hydrograph, P3, P4, and then the storm hydrograph here is the Q. And what I fill in here then is P1 times each of these values. So P1 times 0, P1 times 200, P1 times 450, and 650, and so on. For P2, well, precipitation in the second hour begins here. It doesn't begin at this point, it begins between hour 1 and hour 2. Okay, so P2 times 0, and then we fill in this way. Again, for P3, there's another hour's lag, so it starts 1 hour later. For P4, another hour's lag, so it starts again 1 hour later. Okay, so that's my lagging procedure. And then the adding is just adding across these columns. So P1 times 200 plus P2 times 0. And then for the next Q value, P1 times 450 plus P2 times 200 plus P3 times 0. And then by the time we get to the next hour, we've actually got the 4th hour of precipitation in there. Okay, and you can see there's a number of different patterns. The first is, this is the entire first column, the second column, the third, and you can see that the numbers move downwards by 1 hour. That's the lagging, of course. It's important to note that I'm using these central columns here. This is, again, just for reference, so I don't add these values in. Okay, so be very careful about that. This is just for reference so that it's easier to transcribe the values here. This is not actually added into the storm hydrograph here. Lots of students make that mistake. Make sure that you just sort of blank it out when you're trying to do the add and lag procedure to get your discharge here. This is the end of video 4.